Observe the purple dots disappear as you concentrate your attention on the mark. Trox's fading is the name of this optical illusion, which you have likely seen before. But why do the purple dots fade? Within the mammalian nervous system, there are billions of nerve cells, often referred to as neurons, a collection of which forms the nerve. On basis of function, we have three types of neurons: the motor neuron, relay neuron, and sensory neuron. Sensory neurons transmit electrical impulses as signals from the simulated site to the spinal cord and the brain. The relay neuron receives information from the sensory neuron and transmits the impulse across the central nervous system. Motor neurons then innervate effector muscles and glands, enabling both voluntary and involuntary movements. However, the stimulus that initiates the transmission of these impulses must first cross a threshold. Much as riding a roller coaster requires us to be of a certain height. The receptor cell cannot trigger the sensory neuron to send impulses if the receptor potential is below the threshold. Strong stimuli that are above the threshold cause the receptor cells to depolarize, triggering the sensory neuron to fire impulses which reach the visual cortex, allowing the purple dots to be visualized. Your brain stops recognizing the purple dots while staring at the mark because the stimulus from the purple dots become progressively weaker until it can no longer cross the threshold to transmit new impulses. This occurs when any constant stimulus causes an individual neuron to become desensitized to that stimulus due to the local neural adaptation of the rods, cones, and ganglion cells in the retina. In a nutshell, neurons are among the most fascinating cell types in our body, in charge of both the most complex and the most fundamental tasks. From blinking to thoughts about rocket science, neurons cover it all.